First, you need to know something about how to measure magnetic fields. This device can measure magnetic fields in 3 axes at the same time. You can see it measures the most in the x-axis. But if you turn the power adapter, now it measures the most in the y-axis. When we take the power adapter away, all numbers drop to almost 0 in all axes. Devices like these that have a triple axis mode calculate the magnetic field for you from all 3 axes. This means you don't need to turn this device around to measure magnetic fields. For a device like this that is single axis, you need to turn it in all axes yourself to measure magnetic fields. However, most of the time this device will measure the most in this axis. But for other devices this can be different. This Logitech wireless mouse will be used for the testing. There are 3 different ways this mouse produces EMF. What you hear now is the mouse being in some kind of standby, which is what it does if you don't move it for some time. If you move the mouse, it makes the most EMF, but it's less high if you don't move it for a moment, which looks like an in-between standby mode. This telephone pickup coil plus mini amp will be used as a reference so that I and you know if the mouse is on and what it's doing. This Meterk is the first device to be tested. The Meterk has a single axis magnetic mode and measures nothing in this axis. The telephone pickup coil has a true sound function. This Meterk does not have this. It can just beep when EMF is high. It also measures nothing in this axis. This Meterk device is either not sensitive enough or its frequency range is too limited. In this axis, this device also measures nothing here. This device also does not have a true sound function. In this axis, this device also measures nothing here. This device is also either not sensitive enough or its frequency range is too limited. This device is what some people call a genuine K2. It detects nothing in this axis. It also detects nothing in this axis. This device has a sound function, but it's not a true sound function. This device is also either not sensitive enough or its frequency range is too limited. This orange device does not have a sound function for magnetic fields. This device also does not measure magnetic here. It does measure RF, but that is not what this test is about. They say this device has a triple axis magnetic mode, but let's test all axes just to be sure. It doesn't measure any magnetic from this mouse, so this device is also either not sensitive enough or its frequency range is too limited. This Eric-Hill device very likely has a single axis magnetic mode, since the manual doesn't say. It measures nothing here. This device also does not have a true sound function, just some beeping when EMF is above a certain threshold. This device is also either not sensitive enough or its frequency range is too limited. This device doesn't go to zero in magnetic mode, so you need to keep this in mind when measuring. It keeps jumping between 0.3 and 0.4 milligauss so far, so I think it doesn't measure something yet. Now you can see 0.5 milligauss. On this side you can see a jump to 0.6 milligauss. It is measuring some magnetic fields, but it's not that obvious. You need to do a lot of effort or you may miss this. This footage is for comparison with some of the following devices. You can see that it's not really detecting something here. It's just at its lowest point. This device should have a triple axis magnetic mode. So I shouldn't check all axes, but let's do it anyway to see what happens. Again, it barely detects something from this mouse. The sensor is probably in the exact hotspot of the magnetic field here, which may be why it measures more than before, because this device is supposed to have a triple axis magnetic mode. This is what some people call a fake K2. Ironically, this device looks more sensitive than the so-called genuine K2. This device has no sound function. This K2 looks more useful than the genuine version because it actually detects something from the mouse. And it's cheaper too. In this axis, it detects nothing. .1 microtesla or 0.1 milligauss is its lowest point in this mode. This cornet does not have a sound function for magnetic fields. With this coordinate you don't have to do a lot of effort. You can see that it measures something almost everywhere here. When you don't activate the mouse, this coordinate is also giving us useful feedback. When I'm taking the telephone pickup call away, you can see nothing changed. This was just to prove that we measure something from the mouse only. In this axis, the coordinate is also giving us useful feedback. It would be hard to miss the magnetic field from the mouse with this device. And in this axis it also gives us useful feedback. This tri-field is at its lowest point here in standard mode. It's not measuring something yet. It has a useful sound function, but it's not a true sound function. This tri-field should have a triple axis magnetic mode. When very up close, it starts detecting. A small distance from it, it is not measuring much though. In weighted magnetic mode, its lowest point is 0 here. So it's easier to see if it measures something from the mouse. The peak already picked something up here. In weighted magnetic mode, it detects something further away than it did in standard mode. This PF5 reacts from a distance to the mouse. It's hard to miss. This device doesn't have a sound function. It looks like a very useful device for magnetic fields. This device is likely single axis because the manual doesn't say. The lowest point of this device in magnetic modes is about 0 or 1 nanotesla. So this device is already measuring something here. But it's from the house, not from the mouse. When it starts jumping to 4 nanotesla or higher, I think it starts picking up the mouse. A better test with this device would have been in a field or forest to see how far it can pick up this mouse. This device is sensitive enough to pick up the magnetic field from this mouse. It would be hard to miss it in this axis. This device has a single-axis magnetic mode. This device has a useful and likable sound function, but it's not a true sound function. in these two axes it wasn't picking up as much as like in the first axis tested. This is the dirty electricity mode of this device. It is a very sensitive and useful mode. Because this device is so sensitive and measures very low magnetic fields, it could pick up dirty magnetic fields from a large distance.